Hello, everyone, and thanks for joining the session Databases Don't Fit or Do They? My name is Volker John, and I am going to present to you Backend as a Service from Actian. It's a new offering that, in a nutshell, turns databases into microservices. I structured my presentation into three parts. First of all, I want to do a little bit of level setting, what type of challenges we see in today's software engineering practices, particularly with moving to the cloud, using Kubernetes, running databases, and so on and so forth. Then I will try to tie those challenges and explain what Backend as a Service actually is, and I will close out my presentation with a quick demonstration. And I also want to make sure that we have a common understanding who should be in the audience for this session. And I've got two main people or groups of people here that I believe should be in this session. First of all, software engineers, irrespective of your level in your organization, whether you're a CTO or a starting programmer, right? Doesn't really matter. We will be discussing the shiny new world of using databases via microservices in new or migration projects of legacy applications. Second, if you're in IT, then this session should be interesting in a similar fashion, because I will be covering how you would deploy Backend as a Service. So if software development actually decides that this tool is for them, then I will give you some insights about how it's working, what new components you should be expecting aside from the database, and so on and so forth. If you're in analytics, this session could be interesting for you, particularly if you're interested in the specific aspects of building data applications, right? Getting data out of a database to integrate with other software applications. And I've promised that I would do some level setting first. So from our perspective, and this is based on the fact that Actian has been around for quite some time, right? And you as our customers have been around for quite some time, at least that's what we believe for our traditional database applications. There are two things that usually happen in this situation, right? First of all, existing applications tend to show their age. They have been written years and years ago, and thus they might be in a situation, they might be in a setup where it's hard to actually do newer types of deployments for them, like making a web application on top of them or building a mobile client. And on the other hand, we see that not only we as Actian, but also you as our customers are moving and building towards the cloud. You build new applications to be run in the cloud, and we believe that's actually pretty hard. There are some common approaches to solve this challenge. Obviously, there are lots of frameworks in the variety of languages you use for web development, right? There is the notion of building microservices so that you can actually exchange components of your application without causing downtime and so on and so forth. But at the same time, you're chartered with actually preserving the investment, and that is something that can be done by preserving the existing data or the existing know-how when it comes to operating systems like a database, which usually is quite hard. And we believe that Backend as a Service from Actian actually is one piece, or could even be the solution for you if you're looking at the challenge of either re-architecting your legacy applications or building new applications in the cloud. As I've said, it turns a database into microservices, which could then be used to actually either be consumed in a re-architectured application or in a completely new greenfield project, right? And the important thing is that that is something that is traditionally very hard. Operating a database in connection with microservices creates all sorts of specific problems. And before I delve into the details of what Actian Backend as a Service actually does and how it operates, let me just highlight a few of those challenges in a more deeply engaged fashion. First of all, there are limits to what you can do in the cloud, right? It breaks all the time. If you don't have heard or have not heard that before, then you should actually take this from an expert. We are building software in the cloud, and trust me, it breaks all the time. So you have to have something that is resilient. And databases are not always happy when you tear down one of their instances when it comes to reorganizing data and so on and so forth. It's also hard because you have to take into account that you are not operating the hardware your software is running on, so security is really important. And there are other things that come as a challenge with the cloud. Similarly, you should consider using Backend as a Service, even when you consider deploying on premises. So if you don't want to go to the cloud because your data is sensitive or similar, you might still have a use for Backend as a Service because you want to re-architecture your existing application. And why would you want to do that? Pretty simple from our perspective, right? If an application has grown over years, it becomes really hard to make changes. It becomes risky to roll out updates. Sometimes it's really complex to roll out updates. And there is one thing that everyone is mostly aware of these days, and that is you're limited in terms of scalability, right? You didn't plan for massive scalability of, people call it web scale, right? Deploying mobile applications or browser-based applications. And that means the only way to scale applications that have been built a while ago usually is that you put more cores and RAM into the machines you're running them on. And that actually becomes exponentially expensive the more of those you need, right? The common way in the cloud, and that is why I started with that actually, is you just use commodity hardware. Even in your modern data centers, you just use commodity hardware and then put virtualization or Kubernetes on top. And there's another reason why you might want to consider Backend as a Service that is pretty specific most of the times, right? If you have old applications, they might have been written in a very old language where it's hard to attract talent, to find new people who actually are either willing to learn this particular language or have existing skills in that particular language. And you can see that when it comes to popularity of programming languages, right? Python and JavaScript have been at the top, whereas many of the older applications have been written in C++, C#, Java, or any of the languages that have been around for quite some time. Right? So there are many changes in terms of the paradigms that we're looking at. And if you are hit with any of those paradigm changes, then you should actually consider looking at Backend as a Service. And I promised that I will use these arguments to actually motivate what Backend as a Service is all about. And I'm getting to it, right? So let me first start with a very specific item, which is the scalability part or the performance part of building fast cloud-based applications. There are ways you have been doing that in the past, right? Everyone is probably familiar with three-tier architectures. If you have built something in the last, let's say, 5 to 7 years, then you will probably know about single-page applications or adaptive applications and database as a service, where you actually connect to a backend that someone else manages and scales it for you, unless you try to run that yourself. But there are many pitfalls which are actually connected to building applications in this way, right? There are too many resources. If you do server-side rendering to actually have thin clients, it forces the clients to wait. And you know how users are, right? Wait time is deadly. They have to wait too long, they're gone. You're not selling anything, or whatever the business is you're in. I already mentioned the server must be scalable. And yeah, that can be done by putting lots of hardware into the server, but it becomes more difficult if you actually think about horizontal scalability, because then you're discussing shared state and you have multiple processors who are actually running in parallel, and they sometimes need to have the same state. And that becomes even more of a burden when you think about databases, right? There it is really important to have consistent results. You can't sell the same car 2 times, and you have to take care of that at least, or the latest at the database level. There are many more things that you need to take into account. The main message here is fast cloud-based applications are hard to build. Backend as a service tries to help with that. And it still sits on top of a database. So there's no way around that. In the end, there is a database. But what it does, and I mentioned that, is it actually abstracts the database layer and puts it or meshes it into a number of REST APIs. And that is something substantially different from what you have been using in the past, at least as far as I can tell. You probably have used OBDC or JDBC to connect to your relational databases. You probably have used some specific client library to connect to NoSQL databases, whichever you might have experiences in. And there is one thing that these two things have in common. They may even be standardized, but they're not actually using HTTP in the most cases. But there are libraries that actually do that, which is good. But the truth is that most of these methods of connecting to a database are pretty thick. They're not really built to enable scale and portability. So that is one thing, and it's the main thing that from our perspective is important to understand about BaaS, right? Because building on those REST APIs, everything else can follow. For example, now that you have something that is actually using HTTP or HTTPS, you can scale it by putting a load balancer in front, or by utilizing caches wherever they are. There are browser caches, which you probably know, but there are caching servers all over the internet. And if you know how to integrate with these, then you can actually cache certain aspects of your application and even of your data. And throughout this presentation, I will mostly refer to Actian NoSQL, but Backend as a service is extensible, and there is work being done on supporting ActionX or Ingress for that matter. So, in a nutshell, we put a database into the form of a number of REST services. This enables you to use a lot of the mechanisms that are available for HTTP or HTTPS-based communication in the internet. But there is more to it. There is a complete SDK on top that we will be taking a brief look at during the demonstration. But how is this different from building applications the old way, right? And from my perspective, there are a couple of items. I won't go into too many details, so if that is something you're interested in, you should definitely reach out. So from my perspective, everything related to BaaS runs in a container. And that gives you a lot of flexibility when it comes to deploying things, right? It's possible to spin up containers in Kubernetes everywhere. On-prem, we'll see my demonstration runs on my local machine. You can put them in the cloud. There is little difference when doing so, right? And users these days actually expect to have the freedom to use any programming language of their choice, right? Because they will want to use whatever gets the job done. And using REST services, it's obviously possible to do that. I don't think I have to explain the security aspect, right? If it's HTTP, you can easily encrypt it so that it's HTTPS. No challenge whatsoever with BaaS when it comes to the communication. And then because we're hiding, not hiding in a bad sense, but because we can put so much standard conforming infrastructure in front of Backend as a service and microservices, you can actually do live updates by doing canary deployments or blue-green deployments, whatever method the cloud community has come up with in a similar fashion. We believe that's actually great, and it's a substantial difference to what you would have to do with an application that is still a legacy application. Whether it's client-server or 3-tier, doesn't really matter. Updates are always hard in that scenario, particularly when it comes to keeping compatibility between older versions, newer versions, making sure that the rollout is actually working off a newer version, and so on and so forth. With Kubernetes, with BaaS, it's rollout, controlled audiences, and if it doesn't work, you can roll it back. No one will be harmed, save a few, and then you can iterate faster than you were able to do that before. It doesn't look too different on paper how you would build a web scale application, but I hope that I actually was able to make clear where the differences are, right? The old style, it's hard to scale. If you want to do failover with an application server, let's say in the Java world, you usually have to have a lot of operational knowledge. Sometimes, worst case, you even have to do you have to configure and use third-party software. So there is an added licensing cost. Configuration as code, which is very prominent these days when it comes to creating environments, controlling operations, and so on and so forth, is definitely not part of this world. There are certain aspects of it, but it's not really there. And because the landscape is so diverse, there's a lot of complicated system management, monitoring, and so on and so forth involved. If you put everything into a Kubernetes cluster and everything is just a pod, it all becomes very similar, right? I'm not saying there aren't specific challenges with running a database in a Kubernetes cluster. I'm not saying there aren't specific challenges or configuration options for each of the involved components. That does not go away. But the way you deploy things, whether that's manually or via Helm or other tools that you know better, doesn't really matter. It's always the same. You want to deploy a container, you do that always in the same fashion. You always use the same configuration options. And obviously, because everything is running in the same environment, it becomes really easy to monitor that. And this is what it looks like for an existing or a new project in the Actian world, right? If you run ActianX or Actian NoSQL already, and you have built an application, you don't have to throw away the database instances, right? You would simply deploy the BaaS, the backend application stack, as a service stack, in a Kubernetes cluster and used connections to the existing database instances. This would be different in a new environment, and I have a slight difference here for ActianX and Ingress versus NoSQL. NoSQL has had a recent software release, version 10, where we officially added Helm charts for the product, so it's really easy. And in fact, Backend as a service uses one of those as its dependency, so you would run everything in Kubernetes. Actian X / Ingress is still a little bit of bring your own, and that's why it might be preferred for whatever reason to actually stay outside of the Kubernetes cluster. But again, that's a choice you, the user, can make. And with that, I'm going to show you this right-hand stack with NoSQL live now in the demonstration. So those are just 2 screenshots. Trust me, you don't really have to strain your eyes to watch those or figure out what they mean. I just wanted to make sure there's a visual impression. let me just share my screen and show you what I'm talking about. I already said that everything I am doing is running in Kubernetes, and we can see that here, right? This is a view of my Kubernetes cluster. It has a number of pods, and then I've got a specific namespace for Backend as a service. And if I drill down in the search box, you can see that there are 3 BaaS pods. And that means I already run 3 instances of the system with a load balancer on top, which actually does a round-robin distribution of requests. And to do that is really easy. It's just one parameter in the deployment file. How many replicas do you want? So that's a substantial difference to any other environment. And what does it look like from an, let's say, administrator's perspective? This is the dashboard for the product. So when I click on these, and you'll notice there is no data in here, that is on purpose. I actually access the stack which I have just been showing in Lens. There's just one user in here, which I actually use to log in, conveniently named root. What I'm going to do now is to actually create some more entries. You can see this is a command line application. We'll take a look at the source code in a bit. What you can see here is that I seemingly have created a user. So let's check if I was successful in doing that. Yes, I was. There now is a second one. And going back to the command line, you'll see that I also created some roles. They're not really important for my demonstration here. Suffice it to say, without these roles, I couldn't really do what I'm doing next, and that is creating even more data inside of the system. And again, this is a simple command line application. Obviously, since it's written in JavaScript, you may have noticed that. I'm running a Node application here. You could build something that is running in the browser, right? In fact, you could build anything you want as a front end in JavaScript, and then use the JavaScript SDK that comes with Backend as a service to actually connect to the backend. And if I was successful, then all of a sudden, the entries which were previously empty should now have data. You can see that here. I've created myself as a user in the database. I've created a couple of roles, and then some other entries, which are not really important. What is interesting, though, is to take a look at some of the things we're seeing here. So I have 3 roles, right? So my user here has 3 roles. You can see that here. They're simply referenced by the class name and then the object ID. And I can easily navigate, to those by clicking on the link item. That is all happening in the background. You just have to trust me. That is all stored in an Actian NoSQL database. Now, what was going on in the background? And that is something I want to show you here, just for a very quick overview. There is a schema involved, which is defined in JSON, right? So there is no Java classes or C++ classes or SQL statements to create the schema. You write a JSON file, or you do that manually via the dashboard. Then I mentioned and I ran the credentials JavaScript. In fact, it's a TypeScript, which is then compiled into JavaScript, which I ran. And you can see there is no specific interaction with anything that calls JDBC or OBDC or any gateways or something like that, right? You create a user, you add the user, or you actually add the user to a role, and then you save that, and so on and so forth. And the same for the objects which I created. So if I go here, search for my name, you can see this is the code that was actually used to create me as a user inside of Backend as a service. and then to find all the roles which were in the database. So it didn't really write great code here. And then all of the roles which we just saw in the browser were actually added to my user so that I could do anything on the resulting objects. So what we see here is plain JavaScript. Where are the web services or the microservice, the REST service that I was talking about? This JavaScript SDK encapsulates them, which makes it really easy to interact with Backend as a service if you are a JavaScript programmer. Obviously, you could use curl statements to interact with Backend as a service, or you could use a Python wrapper. We just, to see how it works, actually use Spring Boot to access Backend as a service. There are virtually no limits because REST is a well-defined interface, so you can use it from any language that is capable of creating HTTP requests. We believe that is something that wasn't available in your toolbox before, and that is why we believe that Actian Backend as a service is that important. And with that, let me just stop the screen share again and advance to the next slide. First of all, I want to quickly summarize, right? There are some things that don't really fit a single slide, but there are a couple of things that I really want to point out. Backend as a service provides you with a method to build more resilience in your applications, whether it's new or old applications, right? For new applications, accessing a database as a microservice from other microservices gives you a lot of freedom that will actually go beyond the scope of this presentation to discuss. If you want to reduce monolithic application complexity by converting it either piece by piece into microservices, Backend as a service provides you with a thin persistence layer that coexists with your existing infrastructure and is easy to deploy. I'm sorry I couldn't cover that today, but I'm happy to do that at a later stage. Cost and scale. I believe I made sure, I hope I made sure that that you understand how expensive it can become to scale your existing applications if they're legacy applications. It's becoming expensive because you have to preserve the know-how. It's becoming expensive because changes are complex. It's becoming expensive because it's risky. With Backend as a service, you can re-architecture, you can build afresh with benefits for cost and scale. I showed you the 3 BaaS pods I was running in the Kubernetes cluster, again, I didn't show the load balancer, but there is one in front of it, which actually helps you to scale. More requests, more round-robin trips, more load on the individual pods, and if you have an autoscaler enabled in Kubernetes, it will just scale. I hope that was convincing. What to do next? Talk to us, talk to me, reach out. You've got my email. There is the chat. If you want to move your database into the cloud, if you are considering or are in the process of implementing a new architecture for your application, we should talk. If you need a method to actually reduce your network load or your CPU usage on the database because it's growing and growing and growing and scaling is hard, we should talk. Please reach out to your sales representative or to myself. And with that, I'd like to thank you. I hope this was helpful for you, and I look forward to talking to you. Bye-bye.